Now next question is, use matrix method to examine the following system of equations for consistency or inconsistency. Find the solution if possible. Now this is the system of equations. This system of equations can be written as A is equal to, now how much is A? The quotient matrix 4, 6. Coefficients of y are minus 2, minus 3. And variable matrix is x is equal to x, y. And constant matrix is 3, 5. Now first we find determinant of A. Now determinant of A is equal to this into this, that is minus 12 minus plus 12, which is 0. Now determinant of A is 0. Therefore possibility of unique solution is gone. We will either have infinitely many solutions or no solution. We will have either infinitely many solutions if adjoint of A into B is 0, then we will have infinitely many solutions. And if adjoint of A into B is non-zero, we will have no solution. So what we do is we find adjoint of A. To find adjoint of A. Now replace each entry by its cofactor. So we find cofactors of R1. First row. So this is gone, this is gone. First cofactor is minus 3 and places E1. So E1 is positive and this will be negative. And this is gone, this is gone. So we will have minus 6. Now we find cofactors of R2. Now first entry is this. This is gone, this is gone. And we will have minus 2. But place of this entry is odd. 1, 2, second row and first column. 2 plus 1 is 3. 3 is odd. So we will have a minus sign here. And this will be positive. Alternate plus minus sign. So this is gone, this is gone. And we have 4. That is 2 and 4. Therefore, adjoint of A is equal to, replace each entry by its cofactor, minus 3 minus 6, 2, 4. And take the transpose. This is equal to minus 3 minus 6 and 2, 4. And shortcut is interchange the diagonal entries. So this will become minus 3 and this will become 4. Minus 3, 4. And attach negative sign with the rest. So this will be minus 6, 2. Minus 6, 2 and these will get interchanged. This is the shortcut to find adjoint of A. And therefore adjoint of A into B. This is equal to minus 3, 2, minus 6, 4 into B. How much is B? B is 3, 5. So this is equal to, now we multiply these two matrices. This into this. This will be minus 9 plus 10. This into this. Minus 18 plus 20. Minus 18 plus 20. And this is equal to 1, 2. Not equal to 0. Therefore, the system is inconsistent because adjoint of A into B is not equal to 0 and therefore system is inconsistency. That is, has no solution. The row system has no solution. Now next question is, use matrix method to examine the following system of equations for consistency or inconsistency. Find the solution if possible. Now this system of equations can be written as A is equal to the quotient matrix, quotients of x 4, 5, 2, 4, 5, 2, and quotients of y -5, -4, and 2. Quotients of z -2, 2, and 8. And the variable matrix x is equal to x, y, z, and b is equal to 2, -2, -1. Now first of all we find determinant of A. Do we expand this determinant by R1? So this row is gone, this column is gone. We have -32 -4, -32 -4, and this entry will be, this is plus, this is minus, minus plus 5 into, this is gone, this is gone, 40 -4, 40 -4, and this will be -2, this is gone, this is gone, 10 plus 8, 10 plus 8, and this is -36 into 4, that is -144, that is -144, plus 36 into 5, that is 180, and 18 into 2 is -36, and this is equal to 0. Therefore the system will either have no solution or infinitely many solutions. So we find adjoint of A. To find adjoint of A, we find the cofactors of all the entries. Cofactors of R1. Now first entry is this. So this is gone, this is gone. -32 -4, that is -36. Next entry will be negative, and next will be positive. So this, now delete the row and column in which the entry occurs. This is gone, this is gone. Now delete the row and column in which the entry occurs. So this row is gone, this column is gone. 40 -4, that is 36. Next is, now this is gone, this is gone. 10 plus 8. 10 plus 8 is 18. Now we find cofactors of R2. Cofactors of R2. Now we find cofactors of second row. So first entry is this. Delete the row and column in which the entry occurs. -40 plus 4. -40 plus 4 is -36. And place of this entry is, this is second row and first column, odd. So minus will be plus. Next entry will be positive, and next entry will be again negative. So next, this is gone, this is gone. 32 minus plus 4. 32 plus 4 is 36. Next is this. This is gone, this is gone. 8 plus 10. 8 plus 10 is 18. Now we find cofactors of R3. Third row. First entry is this. This is gone, this is gone. -10 minus plus and 1 minus more. -8. -10 minus 8 is -18. And place of this entry. Place of this entry is 1, 2, 3. third row and first column. 3 plus 1 is even. So we will have plus sign. And here we will have a negative sign. In next entry we will have a positive sign. So now this entry, this is gone, this is gone. 8 minus plus 10. 8 plus 10 is 18. Next entry is this. This is gone, this is gone. Minus 16 plus 25. Minus 16 plus 25. That is 9. Therefore, adjoint of A is equal to. Replace each entry by its cofactor. So this will be minus 36 and 18. This is 36 minus 18. This is minus 18 and 9. Now this matrix can also be written as, we can take 9 common. 9 is common. Now when we take anything common from a matrix, we take it common from each and every entry of the matrix. So take 9 common from each and every entry. This will be minus 4, 2. 4, 4, minus 2. This will be minus 2 and 1. This is adjoint of A. Now we find adjoint of A into B. And this is equal to 9 into minus 4, 2. 4, 4, minus 2. Minus 2, 1. Into B. How much is B? B is 2 minus 1. And this is equal to 9 into. Now this into this. So minus 8. This is minus 8, minus plus 8 and minus 2. This into this. 8, first entry with first, second with second. Minus 8, third with third, plus 2. This with this. This is minus 2 into 2 is minus 4. Second entry with second is plus 4. Third entry with third is minus 1. So this is equal to 9 into minus 8 plus 8 is 0 minus 2. This is 2. And this is minus 1. Which is not equal to 0. Therefore, system is inconsistent. And therefore has no solution. And therefore has no solution. Now next question is, use matrix method to examine the following system of equations for consistency or inconsistency and find the solution if possible. You can try both these questions as we have done in the earlier example. In both these questions, determinant of A will be 0. And when you will find adjoint of A into B, it will be non-zero. And both the systems will be inconsistent. You can try them yourself. I move on to the next question. Use matrix method to examine the following systems of equations for consistency or inconsistency. Find the solution if possible. Now this system of equations can be written as Ax equal to B, where A is equal to, A is the coefficient matrix. So this will be 1, 2, 1, 1, 2, 1. Coefficients of y are minus 1, 1 and 2. minus 1, 1, 2. And coefficients of Z are 1, minus 1 and minus 2. And X is equal to the variable matrix. Variables are X, Y and Z. And B is the constant matrix. It is equal to 3, 2, minus 1. 3, 2 and minus 1. Now, first of all, we find determinant of A. So, determinant of A is equal to. Now, expand this determinant by first row. It will be 1 into its cofactor. This will be minus, and minus minus is plus. Plus 1 into its cofactor. Plus 1 into its cofactor. So 1 into its cofactor. This is gone, we get minus 2 minus minus plus 2. That is 0. Next is, now delete the row and column in which the entry occurs. So this is gone, we get minus 4 plus 1. Minus 4 plus 1 is minus 3. And delete the row and column in which the entry occurs. 4 minus 1. 4 minus 1 is 3. So this is equal to minus 3 plus 3, that is 0. Therefore, determinant of A is 0. Therefore, the system will not have a unique solution. It may have either no solution or infinitely many solutions. This system will have either no solution or infinitely many solutions. So we find adjoint of A. To find adjoint of A. If adjoint of A into B comes out to be non-zero, then the system will have no solution. And if adjoint of A into B is 0, the system will have infinitely many solutions. So we find adjoint of A. To find adjoint of A, we find cofactors of each and every entry of this matrix. So first we find cofactors of R1. Now first entry is this. Delete the row and column in which the entry occurs. So this is gone, this is gone. We get minus 2 minus minus plus 2. That is 0. And place of this entry is even, 1, 1. This will be negative. So minus this. This will be plus. So this will be plus. We will have alternate plus minus sign. Plus, minus, plus. So this is 0. Now delete the row and column in which this entry occurs. This is gone, this is gone. We get minus 4 minus minus plus 1. Minus 4 plus 1 is minus 3. Now next entry is this. So we get 4 minus 1, that is 3. We find now cofactors of R2. Cofactors of R2. Now this place is odd place, so we will have minus. Next will be plus. And next will be minus. Alternate plus minus signs. So now we come to this entry. Now delete the row and column in which this entry occurs. So this into this is 2, 2 minus 2 is 0. Next will be this. So delete the row and column in which the entry occurs. This is gone, this is gone. We have minus 2 minus 1. Minus 2 minus 1 is minus 3. And next is this. Delete the row and column. So we will have 2 plus 1. 2 plus 1 is 3. Now we find cofactors of R3. Cofactors of R3. Now place of this entry is 1, 2, 3. Third row, first column. So 3 plus 1 is even. So we will have plus. So this will be plus, next entry will be minus, and next will again be plus. So what we get is first entry of this row is this. Delete the row and column. This will be minus minus plus 1 minus 1. 1 minus 1 is 0. Next entry is this. Delete the row and column. So this will be minus 1 minus 2. Minus 1 minus 2 is minus 3. Now this entry. Delete the row and column. 1 plus 2. 1 plus 2 is 3. Therefore, adjoint of A is equal to. Now replace each entry by its cofactor. So replace all the entries by their cofactors. So this will be 0 minus minus plus 3 plus 3. This will be 0 minus 3 minus 3. This will be 0 minus minus plus 3 3. And transpose of this will be adjoint of A. So this is equal to, now this row will become first column 0 3 3. Second column 0 minus 3 minus 3. Third column 0 3 3. J interchange rows and columns. So adjoint of A is equal to this much. Therefore adjoint of A into B is equal to 0 0 0 3 minus 3 3 3 minus 3 3 into B. How much is B? B is 3 2 minus 1. 3 2 minus 1. So this is equal to, now this into this 0 0 0. This will be 0. Now this 3 3s are 9. 9 minus 6 minus 3. Next will be this into this. So this will be 9 minus 6 and minus 3. So this is equal to 0 0 0. Therefore adjoint of A into B is a zero matrix, and therefore this system of equations is consistent and has infinitely many solutions. Therefore this system will now have infinitely many solutions. If this is non-zero, then no solution. But this is zero, therefore this system will have infinitely many solutions. Now what we do is put z equal to k in any two of these equations and solve the resultant system of equations for x and y. Now let z be equal to k. Now take any two equations. We take first two equations. We will get x minus y plus k is equal to 3. And second is 2x plus y minus k is equal to 2. And this implies x minus y is equal to 3 minus k. And 2x plus y is equal to 2 plus k. Now we will solve this system of two linear equations. So this can again be written as ax is equal to b, where a is equal to the quotient matrix. Quotient matrix will be 1 2. This will be minus 1 1. And x is the variable matrix. Here we have only two variables, x and y. And b is the constant matrix. We have 3 minus k and 2 plus k. Now to solve this, we find A inverse. To find A inverse. First we find adjoint of A. Adjoint of A is equal to, now we have a shortcut for this. Interchange the diagonal entries, that is 1, 1, and attach negative sign with the others, that is -2 and 1. This will be adjoint of A, and A inverse is adjoint of A over determinant of A. This is equal to determinant of A. 1 minus plus 2. 1 minus plus 2. 1 plus 2 is 3. So 1 by 3 into 1, 1 minus 2, 1. This is A inverse. And therefore X is equal to A inverse B. And this is equal to A inverse. How much is A inverse? A inverse is 1 by 3, 1, 1 minus 2, 1 into B. B is 3 minus K, 2 plus K. So this is equal to 1 by 3 into this, that is 3 minus K plus 2 plus K. And next is this into this, minus 6 plus 2K, minus 6 plus 2K. This into this, this into this, this into this, plus 2 plus K. So this is equal to 1 by 3 into 3 plus 2 is 5, K and K cancel. This is 5. And this is minus 4 plus 3K. 3K minus 4. Now X is XY. So XY is equal to this one. This implies X is 5 by 3 and Y is 3K minus 4 by 3. And therefore required solution is X is equal to 5 by 3, Y is equal to 3K minus 4 by 3, and Z we have assumed to be equal to K. Z is K. This is the answer. And different values of K will give different solution. K equal to 1 will give one solution, K equal to 2 another, K equal to 3 another, 1.1 one more solution, and similarly you can generate infinitely many solutions, and all these solutions will satisfy the given system of equations. Now next example is this. You can try this yourself. This system has infinitely many solutions, and what you will get is you will get determinant of A equal to 0, and therefore you will find adjoint of A. And when you will find adjoint of A into B, it will come out to be 0. And the system will have infinitely many solutions. And therefore you will let Z equal to K in any two of these equations and solve them for X and Y. Now next is, we are given two matrices. We have to find AP. And using this, we have to solve this system of equation. So first we find A into B. A into B is equal to, how much is A? A is 1 minus 2, 0, 2, 1, 3, 0 minus 2, 1. And B is 7, 2, minus 6, minus 2, 1, minus 3, minus 4, 2, and 5. We have to multiply these two matrices. So what we do is first row with first column. So this will be 1 into 7 is 7. Minus 2 into minus 2 is plus 4. 0 into this is 0. This into this. 2 into 1 is 2, minus 2 and 0. 2 minus 2 and 0. This into this. Minus 6 plus 6 and 0. Minus 6 plus 6 and 0. Next is this into this. 14 minus 2 minus 12. 14 minus 2 minus 12. This into this. 4, 1 and 6. 4 plus 1 plus 6. And this into this. This will be minus 12 minus 3 plus 15. Minus 12 minus 3 plus 15. This into this. This will be 0 minus minus plus 4 minus 4. 4 minus 4. This into this will be minus 2 plus 2. Minus 2 plus 2. This into this. Minus minus plus 6 and plus 5. 6 plus 5. So we will have, simplify this. This will be 11, 0, this is again 0, this is 0, this is 11, and this is 0, 0, 0 plus 6 plus 5. So it will be 11. So this is equal to 11 into I3. Therefore AB is 11 into I3. Let us call this as 1. Now this system of equations can be written as, we have already used the notation A. So for our system we will have another notation. This system can be written as Px equal to Q. Instead of Ax equal to B, we take Px equal to Q, because AB notations have already been used in the question. So this is P is the coefficient matrix, coefficients of x, 1, 2 and 0. There is no term containing x. So this will be 1, 2, 0. Coefficients of y, minus 2, 1, minus 2. Minus 2, 1, minus 2. And coefficients of z. Coefficients of z here is 0. Here it is 3 and 1. 3, 1. So P is this much. And X is X, Y, Z. And constant matrix is 10, 8 and 7. And solution is X equal to P inverse Q. P inverse Q. Px is equal to Q. Multiply both sides by P inverse. P inverse into Px is equal to P inverse into Q. So this will be P inverse P into X is equal to P inverse Q using associativity. So this will be Ix is equal to P inverse Q, and therefore X will be equal to P inverse Q. So this is the solution. X is A inverse B. Instead of A we have P, and for B we have Q. Now this matrix is same as A. A is 1 minus 2, 0. 2, 1, 3. 0 minus 2, 1. So this is same as A. And 1 implies P into B is equal to 11 I3. And therefore P into 1 by 11 B is equal to I3. This implies 1 by 11 B is inverse of P. That is P inverse is equal to 1 by 11 P. So P inverse is 1 by 11 of this matrix. We get P inverse from this equation. So we have to find this and hence solve. We have to find AP and hence using this we have to solve this system equation. So we use this to get P inverse equal to 1 by 11 B. Now we will solve this system equations using 2. You can see the last sheet as a side sheet. So what we get is from 2 x is equal to P inverse Q. But P inverse is 1 by 11 B and Q. So this is equal to 1 by 11 into B. How much is B? B is 7, 2, minus 6, minus 2, 1, minus 3, minus 4, 2 and 5. And Q is 10, 8, 7. So what we get is 1 by 11 into this into this. This will be 70 plus 16 minus 42. This into this, minus 20, 8 and minus 21. This into this, minus 40, first entry with first, second with second, plus 16 and third with third, that is 35. And this is equal to 1 by 11 into. Now this is 86. 86 minus 42 is 44. We have 44. This is minus 20 minus 21 minus 41. Minus 41 plus 8 is minus 33. And minus 40 plus 35 is minus 5. Minus 5 plus 16 is 11. And therefore, this is equal to 4 minus 3 and 1. Multiply each and every entry by 1 by 11. So 4 minus 3 and 1. Therefore, x, y, z is equal to 4 minus 3 and 1. Therefore, x is equal to 4, y is equal to minus 3 and z is equal to 1. This is the answer. You can verify the answer by substituting in any one of the equation. I substitute in second equation. Substitute in this. It will be x is 4, y is minus 3 and z is 1. So 3 and 3 cancel, we have 8 equal to 8. Verified. So we have checked that our answer is